Today we'll discuss about noble gases or group 18 elements. First of all, where are the noble gases lies in the periodic table? It is known to us noble gas lies at the extreme right of the periodic table. They are known as group 18 elements and comprises of helium, neon, argon, potassium, xenon, radon, and organoxene. Organoxene is the most recent edition of noble gas element, which is extremely radioactive. As I mentioned, group 18 elements placed extreme right are known as noble gases. These noble gases are also known as inert gases because they are chemically inert. And also they are known as rare gases. Why rare gases? Because their abundance is quite low as compared to the other naturally available elements. Occurrence of noble gases. Out of all the seven noble gases, helium, neon, argon, krypton, and xenon are available. And it was first obtained by Cavendish in 1874 as a these gases. What Cavendish had done? Cavendish first of all removed nitrogen from air by adding excess of oxygen and sparkling. And the reaction between nitrogen and oxygen leads to the formation of nitrogen dioxide, which was absorbed in sodium hydroxide solution. Furthermore, the excess of oxygen remaining in the solution is removed by burning sulfur, which results in the formation of sulfur dioxide in sodium hydroxide solution. This produced a small volume of mixture of unreacted gases like neon, argon, krypton, xenon. Helium is generally recovered from natural gas deposits where hydrocarbons are liquefied, leaving helium gas. Argon is recovered by fractional distillation of liquid air. It originates in air from beta decay of potassium. This is the reaction. Perhaps you don't have any idea about the role of beta decay on this group displacement law. I am summarily explaining these things. Upon beta decays, in every atomic number decreases by 1 and mass number increases by nil. That is, mass number remains the same and atomic number decreases by 1. Here you have seen that potassium having the atomic number 19 is get converted to the atomic number 18. Mass number is unaffected after beta decay. Radon is radioactive produced by the decay of radium and thorium minerals. This is the reaction. It is formed by the alpha decay of this radium. The alpha particles, this is alpha particles, they are also known as helium nucleus. Physical properties of noble gases. Noble gases are colorless, odorless, and we know it is a monatomic gas. It was first discovered by Ramsay. Radon and organoxene are radioactive in nature because they are not available in nature. Argon is the most abundant noble gas. All noble gas can be liquefied provided the proper conditions are maintained. Except helium, all the noble gases have 8 valence electrons. Helium only have 2 valence electrons with 1s2 configuration. And it is the second most abundant element in the universe. And the source of helium is basically the primary sun is the primary source of helium. The general electronic configuration of noble gas is Ns2 Npc. It possesses zero electron affinity and high ionization energy. Why zero electron affinity? Because its shell is completely filled, so it is reluctant to receive any more electrons in its shell. Similarly, why highest ionization energy? Because of completely filled shell, these electrons are tightly held to the nucleus, and that is why difficult to remove it. Enthalpy of evaporation is quite low because of uh, because they are held together by very weak van der Waals forces, and it increases down the group due to increase in the polarization. That means, if you move from top to bottom in the group or in a noble gas group, enthalpy of evaporation increases. Boiling point melting points are also low, and it increases down the group. This is also because of this weak van der Waals force existing between them. Helium is known to be the lowest boiling liquid with boiling point of minus 260 degrees centigrade. This is basically the electronic configuration of valence shell, Penrose radius, and ionization energy of chemical properties of noble gas. Although noble gas are chemically inert, but there is some chemistry still be found in, especially in case of xenon and some of the krypton compounds. Noble gases are chemically inert due to completely filled electronic shell, like highest ionization energy and zero electron affinity, it was already discussed. Under certain conditions, some of the noble gases can form compounds, especially xenon and krypton. The noble gas from hydrate also by hydrate with water, but these are not chemically held together. That's why they are not considered to be the true chemical compounds of noble gases. The hydrates of these gases are formed by compressing the gases with water. For example, it has a composition of X6H4. It is 6 water molecules against each noble gases. Similarly, by trapping also noble gas can form compounds, and these compounds are known as clathrates. Clathrates are also held together by non-covalent interaction. That is why they are also considered to be not not considered not to be the chemical compound of noble. How clathrates are prepared? Basically, noble gas with appropriate size with certain organic molecules, maybe sometimes inorganic molecules are also there. They are fit in the cavities and resulting the though the gases are trapped, they do not form bonds. Helium, neon, argon do not form any other compound due to their extremely high ionization energy. That means their electron moving is quite difficult and so they are unreactive as compared to the noble gases. The ionization energy of krypton is lower a bit. That is why it is forming some compound, especially with fluorine. Although ionization energy of radon is lower than xenon, because its radioactivity, no stable isotopes of radon are available and hence no chemistry of radon is found, except in few cases. However, xenon has quite extensive chemistry in the form of compounds of in the form of fluorides, in the form of oxide, in the form of oxyfluoride, even in some kinds of complex oxygen ion like arsenate. Oxygen compounds of xenon can be obtained from fluids. However, direct preparation of oxides of xenon is quite difficult or quite difficult in the laboratory. Rationalization of inertness of noble gases. Why noble gases are inert? The primary reason is basically the unavailability of the orbital or and high ionization energy and low electron affinity. First of all, it has complete pairing of all the electrons. The stable electronic configuration of NH2 NP6 is responsible for the inertness of this element. Then very high ionization energy due to stable electronic configuration, a large amount of energy is required to remove an outermost electron, and hence do not form the ions very easily or under ordinary conditions. Then zero electron affinity due to the stable electronic configuration. These elements have no tendency to form anion or to receive electron, and hence they are chemically inert. Absence of extra bonding orbitals. Due to the absence of any extra bonding orbital, the atoms of these elements do not form any bonds with other atoms. Although these factors are against the reactivity of noble gases, still there is some active chemistry of krypton and xenon. Krypton and xenon are known to form compounds with oxygen and fluorine. However, the chemistry of krypton is nominal, whereas chemistry of xenon compounds is quite extensive. Generally, the reactivity increases as we move down the group. That means radon will be more reactive than xenon, xenon is more reactive than krypton, krypton is more reactive than argon, followed by neon and helium. Now, clathrate are noble gases. As I said, clathrate compounds are basically host gas kind of compound. The first chemical compound of noble gases is known to be clathrate. How they are formed? Clathrate is a case-like compound where there is a host molecule, there is a guest molecule. In general, the noble gases are the gas molecule and the organic or inorganic group. These are host molecule, and the noble gases are fit within the hole produced by this organic or inorganic compound. Classes is a case compound in which noble gas atoms with suitable size are trapped in the crystallization of the suitable organic or inorganic compound. Now, the most important part is the suitable size. Why suitable size is most important? Because if the cavity is larger than the noble gas, then this noble gas will not appropriately fit in the cavity. It will easily escape. So, in that case, the calcium compound will be less stable. However, if the noble gas is larger than the whole produced or lattice produced, then it will not go inside the lattice. As a result, it will not be a stable one. Though the gases are trapped, they do not form bonds. These are common classic compound preparation. If an aqueous solution of quinone is crystalline under the pressure of 10 to 40 atmosphere, in presence of argon, krypton, and xenon, the gas gets easily trapped within the cavities, and the size of the cavity is about 4 Armstrong diameter. The composition of these classic compounds correspond to 1 noble gases, whereas it is of hydrates, it was 6 water and 1 noble gas. This is basically the general representation of this classic compound. So it will be asked during exam, but you have to have a fair bit of idea about this. Now you see, this is the lattice. If this is very small, what will happen? It will easily come out of this lattice and the compound will be unstable. However, if this noble gas is quite large, then this noble gas will not be getting fit in the hole produced by the lattice. And in that case also the compound will be unstable. And this each of them is held together by hydrogen bonding. Now if I somehow break this hydrogen bonding, then what will happen? The stability of culture will be very low. When the catalyst is dissolved, the hydrogen bond arrangement of beta quinone breaks down. The noble gas escapes. That means it is unstable if it is dissolved. Argon krypton can also be trapped in the cavities. Argon krypton and xenon cavities when water is frozen under high pressure of the gas. In these cases, since water is involved, so instead of hydrate, they are known as hydrate, noble gas hydrate. These are also created with formula approximating 6 water molecule and 1 noble gas. Heavier noble gas, such as argon, can also be trapped in the cavities of synthetic zeolite containing 20% of iron. No clathrate compounds of helium and neon are found. Why? Because helium and neon are too small to get trapped within the hole produced by the beta quinone lattice and so on. This is basically the schematic representation of a clathrate compound. Compound, you know, this I discussed in the